in the B part.
Okay, so first thing we have today, we did the odds earlier for the review. Now we're going to do the evens. And that way you've got the complete review of everything that's going on, so you can see everything that's kind of happening with it. So, all right. So number 2, and kind of do like we did earlier. Number 2, the question is simplify the following expression by combining like terms. So for that one, anything that's x squared, you're going to add those together. So you have the 7x squared that you can do with the 3x squared. And you always take the sign of the numbers that's in front. You have the 5x and the minus 8x. So that 5x would basically be a positive. 8x is a negative or a minus. So you got 7x squared plus 3x squared. That would be 10x squared. 5 minus 8 would be negative 3x, and that would be your final answer. Okay. Biggest thing is when you're adding and subtracting, when you're combining the like terms, you do not change the powers of whatever expression it is that you're working. The only thing you change is the numbers that's in front of your variable. So it's 7 plus 3 and then 5 minus 8. So that gets us the 10x squared minus 3x. All right, number 4. It says, is the equation always, sometimes, or never true? So here's basically what we're going to do. We're going to go ahead and solve this equation that we have, and then after we solve it, we'll see what's left over. So for number 4, pull this down just a little bit. We have 4x minus 16 plus 3x equals 6 plus 7x minus 21. Okay, couple options you can do on this one. Because you've got so much stuff on the left and the right, I would just rearrange these terms so your x's together. So rearranging the terms will make it 4x plus 3x minus 16. On the right-hand side, I would put the 7x first and then just switch these two positions. So then we've got a positive 6 and then the minus 21. And once you've rearranged the terms, now you can, anything that's combined that's together, you can just put these together. So you can do 4x plus 3x and make that 7x. On the right-hand side, you've got 6 minus 21, so you can make that negative 15. So that would make it 7x minus 15. Once you get here, now you start moving stuff from left to right to figure out what it is that you need to do. If we get the x's to one side, let's get rid of the 7x here, so that'll cancel that out. Get rid of the 7x here, that cancels that out. You're left with negative 16 equals negative 15. Can negative 16 equal negative 15? No, right? That doesn't make any sense. If that doesn't make any sense, that is never true. Okay, so if you get to the end and the x's cancel out and you're left with two numbers, basically you tell me, okay, either these two numbers are always true or these two numbers are never true. The sometime was the kind of weird, because if you get to the end and you had, like, let's say you had solved this one and you had like x equals 4, that would be one that would actually be sometimes true, because the only time that makes this thing true is for 4. If you put in x equals 3, it makes it false. So that's kind of the catch on this one. So if you get two different numbers without x's, this is never true. If you get just x equals a number, if you get an actual answer, that's sometimes true. And if you'd gotten to the end and you had gotten like 8 equals 8, well, this would be always true. So that's your 3 possibilities. So two different numbers without any x's at all is never true. The same number twice equal to itself is always true. And if you actually get x equals something, then that one's going to be sometimes true. So that'll be good, especially when you're going into the exam if a question like this pops up. Just kind of walk you through it there. All right, number 6. Another solve equation. This one is an absolute value. So for number 6, we're doing 3 times the absolute value of 2x minus 2 equals 24. So first thing is, if you're solving with absolute values, you have to get the absolute value by itself. So the very first thing we're going to do is divide both sides by 3. And then we've got absolute value of 2x minus 2 equals 8. All right, and remember, absolute value, this is where you have to split up, because the number on the inside, if you had the absolute value of 8, that would equal 8. But if this number was also negative 8, that would equal 8. So this is where we're going to split this thing up and do it 2 different ways. One time where we're going to have 2x minus 2 equals positive 8. The other time we're going to check it to see what happens when we do 2x minus 2 equal to a negative 8. Solve those 2 equations, and then that's the answers we're looking for. So we add 2 to both sides. We get 2x equals negative 6. Divide those 2. And negative 3 is one answer. For this one, we'll add 2. 2x equals 10, and then x equals 5 would be the other answer. Okay, and with Math Excel, again, to make this one work out, this is where when you type this one in, you would type in negative 3, comma, sorry about that. And then you'd put in the, was it negative 3 and 5? Is that answer? Yeah. So you put in negative 3, comma, and then you put your 5. So just put in the 2 answers, separate it by, and it tells you use a comma to separate the answers as needed. Okay, so that's the big thing is, again, when you do this one, you have to get the absolute value by itself first. If you do not get the absolute value by itself first, most of the time you're going to get one correct answer. You're going to get one answer that's going to be incorrect when it comes down to it. So always get the absolute values by itself. All right, number 8. This one is all on the screen here. We're using the slope-intercept form to graph y equals negative 8x plus 3. Use the graphing tool to go back and do it. Okay. So negative 8x plus 3 means we need to start at positive 3 on the y-axis. So start here at positive 3. And then the negative 8 is our slope. But we've got to make it a fraction. So if it's not a fraction, we'll just take the negative 8 and put it over 1. So we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, and then go over 1 to the right. And hopefully the dot is there in the right spot. So again, start at positive 3. Whatever the last number is, it's by itself. The number with the x, that's always your slope. If it's not a fraction, just put it over 1. And the negative tells you whether you're going up or down. You always move it to the right-hand side. So we're going down 8 over 1. We'll save it. And then we check it and make sure that it's good. There we go. And it's good. Because sometimes if that gets a little off, you know, you might be off just a hair. You might have to go back and double check it. If that's one of those that if it counts it wrong, let me know. Send me an email so I can go back and check it. Because sometimes it may be that it just, sometimes it's off by just a hair on the click. So as long as I can match it up and it looks good, then we'll be okay. Okay. Write the equation in slope-intercept form. Find the slope and the y-intercept of the line. Okay. So we've got 4x plus y equals 12, and it says to write it in slope-intercept form. That's basically the y equals mx plus b. So 4x plus 7y equals 12. Which means we're going to get the y by itself. And for this one, it's always the same 2 steps. You subtract or add away the x, whatever that number is. And then once you're there, you go back and divide everything by the number that's with the y. So divide everything by 7. And that equation is the answer in slope-intercept form. Okay, and then the next 2 questions below that, it just says, what is the slope? Well, your slope is negative 4/7. And the y-intercept would be at 12/7. Now, in that case, it came out to be a fraction. That's fine. Whatever the answer is, again, you're not graphing this one, so it's not that big a deal. And it tells you, now, this one it does say, it says type an ordered pair. So for this one, it would be since that's the y-intercept, it would be 0, comma 12 over 7. So you always got to read the directions to see what it asks for. Okay, so there's the equation. Simplify your answer, we're good there. The slope of the line is okay, that's negative 4 over 7. And the ordered pair, again, will be 0, comma, and then whatever this y-intercept is going to be. All right, number 12. Okay, factoring. And this was an easy factoring. We did an odd problem where we had the harder factoring when we were doing some solving, but this one's a pretty easy one. Number 12, and again, what makes this one easy with number 12 is that that x squared term is just 1. So for this one, the only thing you have to do is we're going to find the factors of 32, where the sum is going to equal 12. All right, if you start breaking down 32, good news is they're all positive, so all the signs are going to be positive. And you would think there's more factors of 32 than that, but that's it. It's 1 and 32, 2 and 16, and 4 and 8. The pair to get you to 12 would be 4 and 8. So that's going to be x plus 4 and x plus 8. Okay, so factoring, leave the parentheses there. If it said to solve it, that's where you would take each parentheses and then set it equal to 0, and then go from there. But this one, it said just to leave it factored form, so we'll leave it right there. All right, 14. Got a couple things in it. First thing it says, evaluate the discriminant of the equation. All right, which basically means this is a quadratic formula type question, but we're only going to do the discriminant. And for 14, the discriminant is b squared minus 4ac. So for this equation, we have 4x squared plus 3x plus 6. Okay, there's our a value, is the first number. Whatever's with the x is our b value. The last number is our c value. So we're going to plug in 4, 3, and 6 for a, b, and c. Okay, and again, to be on the safe side, when you plug in these numbers, put parentheses around the numbers. So this is 3 squared minus 4 times a times c. 3 squared is 9. 4 times 4 is 16. 16 times 6 is 96. So if we do 9 minus 96, that's a negative 87. Okay. Now, and sometimes they'll give you, like, we have to do 2 parts. This one, we're going to wait to do it all together. Once you get that number, here's what you have to remember is if that's a negative 87, that this would be the number that would go, if we're going to do the quadratic formula, that number would go inside the square root. If you square a negative number, do you get a real answer? We don't do it. Now, if it was negative, I mean, if it was positive, yes, we could get a number. But remember, if you square root a negative number, that's an imaginary answer. And this one says, how many real answers do we get? Well, they're imaginary, so there's no real solutions on this thing. Check it, and then we're good to go. Okay. The difference is if this number had come out to be a positive number, if it had been 87, we'd have had 2 solutions. If this number had been 0, then you would only have 1 solution. So negative is no solutions. If it's 0, there's 1 solution. If it's positive, then you get 2 solutions. All right, 16. We're going to write this in vertex form, which means we have to find the vertex. And to find the vertex, if you do or don't remember, the easiest way to find the vertex, the x value, which was really the h value, was negative b over 2 times 8. So just like we were doing in the problem up here, we're going to pull out the a and the b values to kind of get what we need. So in this case, the a value would be 1. And the b value is -4. So this is the negative of -4 over 2 times 1. So that's 4 over 2, which is 2. Okay, so vertex, when we talk about the vertex, that's the h and the k. So the h value, which really is like the x value, is the negative of b over 2a. So this one comes out to be 2. Okay, to get the second number, this was where it got a little bit tougher. We're going to take this value of 2, and we're going to plug it back into this original equation we had. So it's going to be 2 squared minus 4 times 2 plus 3. And when we plug that number back in, that's going to be the k value. So if we do that, that is 4 minus 8 plus 3, which is -4 plus 3, which would equal -1. So the vertex for this one would be at 2, -1. Okay, now we've got to go one more step with this thing, because a lot of times people will just put the vertex. It says write the function in vertex form, and this is where we have to take this vertex that we have. Notice I didn't circle this for final answer because we're not done with it yet. Once we've got the vertex, this is where you have to take those numbers and plug it back in. And remember, this number goes on the inside of the parentheses, and this number goes on the outside of the parentheses. For that part, remember, anytime you plug something on the inside, you're going to change the sign. So it would be x minus 2 squared minus 1. And they did not put y. Yeah, they already put the y equals. So that part was kind of given. But that would be the final answer that we're looking for there. So you've got to find the vertex first, and then once you've got the vertex, the first number goes on the inside of the parentheses, and you change the sign of it. The second number goes on the outside of the parentheses, and you do not change the sign of that one. Okay, so just be careful on that one, because a lot of times people will get the vertex and they go, oh, I got it. And then you got to go back and read it, but we're writing it in vertex form. So once you get the vertex, you got to plug it back into that equation. That's the vertex form that you have to do. And somebody may say, what about the a value? Why didn't we put a 1 there? Well, we would put a 1 here, but if you put a 1 in, then it doesn't really do anything. If that value is anything other than 1, then yes, you'd have to go back and put it in there. So this one, there's an understood 1, but again, if it was anything other than 1, you would actually have to put that value of a that's in there. But in this case, the a value is just 1, so we don't really have to have it. If that had been a 3, then yes, you definitely have to put a 3 there for that one. All right, 18, find the zeros. Okay, and this one, again, is a pretty easy one when it comes down to it, because this one, on 18, it's already in factored form. So all we have to do for 18 is we're going to take each parentheses and set each parentheses equal to 0. Okay, subtract 3 from both sides, so x would equal -3. Add 6 to both sides. Add 7 to both sides. And if you notice on this one, they've got the box, so inside your box there, you would just put -3, 6, 7. The order doesn't matter. As long as it's a -3 and a 6 and a 7, where you put the answers, it doesn't matter, just as long as you've got a 6 and a 7 and a -3. Okay, so that was one where it was already pre-factored for you. Some problems, they may say to factor and then solve, but in this case, it was already factored, so all you had to do was solve it. Okay, 20. Oh, that's a good one. We're going to do some synthetic division here. So this would be a good problem. Synthetic division, go ahead and set this up like a normal kind of division problem. We're going to take x minus 7 We're going to divide that into x to the third plus 5x squared minus 5x plus 5. Somebody likes 5s on that problem. Okay, and if you remember, or not, synthetic division, you have to do two big things. First thing is, whatever the number is on the outside, you change this number by changing the sign. So change it from a -7 to a +7. We're going to flip this problem upside down. And again, this is where you leave an extra blank because this is where we're going to show our work in a minute. And in here, you bring down just the numbers. So it's 1x to the third. It's a +5. It's a -5 and a +5. Okay. And the big thing you have to remember on that one is there's two things you have to have. It has to be in descending order. So it's got to be x to the third, x to the second, x to the first, and then just the number by itself. And if one of these numbers had gotten skipped, let's say that they had skipped over the 5x, if that number wasn't there, you'd have to go back and put a 0 in this place. So if they skip over a power of x, if they'd skipped over x squared, if that was gone, then you'd have to put a 0 here in that. You basically got to put a placeholder for each power that's missing. Okay, but they're all there. Everything's in descending order, so we're good to go. First thing is you take the first number and bring it down below the line. And then from here, you multiply. 7 times 1 is 7, and that's a +7. And then whatever these two numbers do, that's what you do. It's 5 plus 7, so that's 12. And then we repeat. Now it's 7, it's going to get big, times 12, which is a +84. -5 plus 84 is the same thing as 84 minus 5, which would be 79. Wow, let's get big. And then we're going to do one more time. 7 times 79, which is going to be 63, 45. That is 533, if my math is correct. Let me double check it real quick. Oh, 553. My bad. Yeah, didn't sound right. Okay. That's why you always double, even if you're doing it in your head, always double check it because sometimes you make mistakes. Add those together, that is 558. Okay, last number is your remainder. All right, the other numbers it says, so that would go here for the remainder block. The other part is going to be these, everything that's left over here. But remember, for these numbers, if you take x to the third and divide it by x, you're always going to knock it down a power of 1. So this one's going to start off with 1x squared plus 12x plus 79. Okay, so x squared we've got plus 12x plus 79. And tab over here to your remainder, that was 558. And we check it, and there we go, and then we're good. Okay, so you've always got to remember to go back and put the variables in there to make it work out. Okay, and again, it's always going to be one less power. So if you started with x to the third, this answer starts with x squared. If you'd started with x to the fourth, this would start with x to the third. So you're always, because you're always going to divide it by x, so you're always going to knock this thing down one power to get it started from here. All right, 22, find the product and simplify. Okay, so for this one, we're going to do some multiplying first. So when you're multiplying, you have to do two different things. You're going to multiply the outside numbers together first. So we're going to do 4 times 2 to get 8 on the outside. And then on the inside, we're going to do 10x times 8x to the 6th. So on the outside, we did 4 times 2, which is 8. On the inside, go ahead and multiply this together. Now, this is one we said where we could go ahead and kind of leave it as 10 times 8. And remember, this is x to the first power. So if you've got 1x here and 6 here, this would actually be x to the 7th power. And you may be saying, why didn't we multiply 10 times 8 together? Because remember, when we're doing these and ask you to simplify, this is where we're going to have to take these numbers and break them back down. So if we do 10 times 8, that's going to be 2 times 5. 8 is 2 times 4, and then 4 would be 2 times 2. All right, and the reason we do that is we've got 8 times. We've got 2 times 2 times 2 times 2 times 5. And we've got x to the 7th. Okay, this is where we get our exit buddies. This is where we got Nemo and Dory and Marlin and everybody. So pair of 2's gets out. There's another pair of 2's. That one gets out. And the 8 was already here. So it's 8 times 2 times 2. The 5 stays on the inside. And with x to the 7th, if you want to think about that one, we said there's a couple different ways, but if you have 7 x's, you have 1, 2, 3. Oops, too many. Wrote 8. Sorry, my bad. If you have 7 x's, you've got 1, 2, 3 pairs that can get out, and then you've got 1 that's stuck on the inside. Okay, so then we're 8 times 2 for 16, 16 times 2 for 32. X to the 3rd, and then the square root would have the 5 and the x on the inside. And somebody was like, what if I put the 80 together? Well, okay, that's fine. If you put the 80 together, if you had done 8 times 10 and gotten the square root of 80, well, then you just have to go back and start breaking down the 8 times 10 and then keep breaking it down from there. Or you could have started with 2 times 40, but it's just a way to save a little bit of time when you go through that part of it. Yeah. So the big thing is, remember that you multiply the outside numbers together. So this was 4 times 2 to get 8. Then you multiply the inside numbers together. And remember, the variables, you just count up how many you have. If there's 1 here and 6 here, then there's 7 total. The numbers, that's the one that you've got to break down so you can find the pairs. All right, 24. This is honestly just a calculator question. You've got 1,000 to the 1/3. They want you to kind of be able to do this without a calculator, but let's just be honest here. Remember the rooftop, if you're using this calculator, the rooftop button is your power button. And if it's a fraction, people are like, I can't do fractions. Yes, you can. Just do a parentheses, and it's 1 divided by 3. The fraction bar, the divide bar is your fraction bar when it comes down to this one. So it's just, and again, there's your rooftop button and there's your divide button. Hit that and tells you the answer is 10. And those numbers should come out to be just, sometimes it might be a fraction, but once you punch these numbers in, it should be just whatever that number is going to be. All right, 26, we've got 5 minus x equals square root of 3. All right, 26. One big thing on 26 that you've got to have is you've got to remember how to get rid of a square root, because we need this thing to be just x by itself without any square roots. So the first thing is, now there's nothing else around it. We did the absolute value problem earlier where we had to get rid of the numbers with it. The absolute value, square root is kind of the same thing. We've got the square root by itself. Now we're going to get rid of this square root. And to do that, we're just going to square both sides. That if we square a square root, they cancel out. So that's 5 minus x equals 9. Oh, sorry, can't see that. And if you want to get rid of the 5, so the x is by itself, that's negative x equals 4. But remember, we got to change this negative x to a positive, so we're basically dividing both sides by negative 1. So x would equal negative 4. Okay. It says use a comma to separate answers as needed. There's only one answer, so you don't have any need of commas for that one. 28. This one's a graph, and it's all multiple choice. So the big thing on this one, and we'll kind of sketch it over here. Sometimes it's good to have a sketch, and this would be one we're definitely having a sketch help you out. It's square root of x plus 3. Okay, so with that one, if it was just square root of x, it would start at 0 and then curve off and do something like that. So the problem with this one is, what does the plus 3 do? Depends on where it is, right? If it's on the inside, it would move it side to side. Since it's outside the square root, that's going to move it up and down. And since it's positive 3, we're just going to move this thing up 1, 2, 3 spaces. So basically, square root of x plus 3 would look something like that. Oh, sorry, I went too far up there. So again, if it's on the outside, it makes it move up and down. If that had been on the inside, that's where you move it in the opposite direction, left and right. So for this one, we need it up to plus 3 is got to be B. That's the only one that's got anything that's moved somewhere close to up. It's a little off because of everything being probably scales of 2 here. But if you notice, there's only one that's here because this one's down, this one's up, this one's left, and this one's right. So they basically were saying, all right, do you know which basic way to move this thing? All right, 30. Ooh, good question here. 4 to the x power equals 5. This goes back to that packet of problems we were doing. Okay, so for number 30, this is an exponential expression. We don't know what 4 to the power is. If this was 16, well, that would be easy. If that was 4 to the 16, 4 squared would be equal to 16, so x would equal 2. But this one's not 16. If it's 4 to the x equals 5, we don't know what that answer is. If this is in exponential form, the big thing is we have to then turn around and rewrite it in log form. All right, and if you don't remember how to put it in log form is, you write down the word log. This is 4 to this power, so the base stays the same. That 4 will go here. You just switch these two numbers. So the 5 goes on the left and the x goes on the right. So again, if it's 4 to the x power, this base stays on the bottom, and you just switch these two numbers. From here, this is a calculator problem. Once you got log of 5 and the base is 4, it's the log of 5 divided by the log of 4. And now some calculators will actually let you put it in like this. Depending on the calculators that you have, the ones that we've got here that y'all are using in my class, these calculators, this one you actually have to go back and punch it in. So there's your log button right there. So we'll do log of 5. And if you do remember on this one, you have to close off that parentheses. If you don't, you'll get the problem wrong. If you want to, you can just hit log of 5 and then hit enter, and then you can do log of 4. And that way it's kind of extra safe on that one. Final answer there is 1.1609. It says to round it to 4 decimal places. So 1, 2, 3, 4. That 6 will bump this 9 up to a 10, so it's actually 1.1610. And we're good to go. Okay. Okay, so that one does two things. Number one, it makes you rewrite something from exponential to log form. And then once you got it in log form, you're going to know how to, you got to remember how to use your calculator. It's always the log of the top number divided by the log of the base. Be able to use your calculator. All right, 2 more to go. All right, number 2, we're going to solve this equation. Ooh, this would have been, in any normal year, this would have been like one of the very first questions that we would have ever done. I think it came a little bit later this year because of everything, but because everybody loves fractions, right? No, nobody likes fractions. So here's what we're going to do. Fractions don't get any love. Easy thing on this one is we're going to get rid of the fractions. So what you have to do is if it's 2 and 5, basically just find the least common denominator of 2 and 5. as long as the numbers are small, the easiest thing to do is just to multiply those two numbers together. So least common denominator is 10. Now, if it was like 30 and 40, you wouldn't want to do that. You don't want to actually find like the first number they'd have in common. But even with 2 and 5, that is the first number that they have in common. Count by 2s, count by 5s. There you go. The first number they have in common is 10. And once you've got that least common denominator, you go back and multiply every single number by your least common denominator. And the great thing that does is when you do that, it's 10 divided by 2, which makes that 5. This one is 10 divided by 5, which makes that one 2. And this is just 10 times 7, which is 70. So now you have all whole numbers. It's 5y plus 2y, which is 7y, equals 70. Divide those two numbers, which means that y would equal 10. Okay, so one of those problems that people look at and they go, oh, it's fractions. Well, it's really not bad at all as long as you know what to do. And again, it's just always two things. Find the least common denominator, whatever those numbers are. And again, if it's worst case scenario, you can always multiply the two numbers together. And then once you've got the least common denominator, you multiply everything by that number, and then the fractions go away, and it's a nice, easy, not too complicated problem to solve. All right, and last question of the year. Find the value of secant of 5 pi over 3 without using a calculator. Okay, which means if you got your sheet that we did in class that day where we filled this thing out, secant of 5 pi over 3 was probably on there. If not, we'll kind of walk you through what to do here. So for 5 pi over 3, find 5 pi over 3, right there. Now, if it was sine, that would be negative square root of 3 over 2. If it was cosine, it'd be 1/2. Because we always say that cosine's the first number, sine's the second number. This one, though, asks for secant. So you've got to remember that secant, pull this down so we've got plenty of room here. Secant is 1 over cosine. Okay, and again, 5 pi over 3, cosine was 1/2. So this one, they're actually a little bit easy on you. So this is 1 over 1/2. Sorry. And if it's 1 over 1/2, this is where you can keep it, change it, flip it. So this is 1 times 2 over 1, which is 1 times 2, which is just 2. Okay, now, and what we'll do is we'll go back and I'll do a worst case scenario. That if this thing had been cosecant of 5 pi over 3. Well, cosecant would be 1 over sine. And sine in this case would have been the negative square root of 3 over 2. So 5 pi over 3, again, this is cosine, this is sine. So at that point, it's 1 over the negative square root of 3 over 2. Okay, if you did keep it, change it, flip it here. You keep the 1 the same, you change this to multiplication, you flip this thing upside down. That becomes 1 times negative 2 over square root of 3. And if y'all remember, if the square root happens to be in the denominator, you cannot leave it there. You would have to rationalize it. And to rationalize it, what we said you would do, again, if it's 1 times, it's really just that number. To rationalize it, we said you have to move the number from the bottom to the top. And on the bottom, you leave just the number without the square root. Okay, so if you do 1 over and it's just a number without any square roots, it's really easy to find that number. Usually, it's not much to it. If you do 1 over a number and it's got a square root in it, then at the end you're going to have to go back and rationalize that number.